Let's get started now with Cuisenaire rods and talk about why are we even using Cuisenaire rods in the first place? Well, if you're like me, I know I initially found these really frustrating. Why are there no notches on it? And how are you supposed to know what each one represents without there being notches on it? Well, as frustrating as that was initially, now that I've seen them used so effectively, I now understand that that's actually exactly what makes them so great. So why Cuisenaire rods? Well, first of all, Cuisenaire rods help students move away from counting individual pieces to chunking. The fact that there's no notches on it means that they can't count. They need to figure out what the length of the whole is and see it as a whole. It also helps to develop the concept of number as a length, so a continuous measurement, rather than individual or discrete objects as it was with the Subotising cards. Cuisenaire rods are also centimeters in length, and so you can actually use them with measuring just like you would use centimeter cubes or other centimeter objects. Another great piece is that Cuisenaire rods can be used to build any math fact with whole numbers or any multi-digit whole number, and we'll look at doing that as well. So we can extend what we've been doing and to work with larger numbers in a more efficient way than counting individual pieces would be all the time. So first of all, let's look at the color category. So many people find it frustrating that they're not in rainbow order, but there actually is a reason to the different color groups. So if you look at the 2, 4, and 8, that's the red, pink, and the brown. Those make the warm colors. And then the 3, 6, and 9 is the light green, dark green, and blue, and that makes the cool color family. The sunny then is the 5 and the 10, so the yellow and the orange. And then left we have the black and the white, which are sort of our unique colors at the 7 and 1. So if it helps, you can actually see that there is a relationship in the color families. All right, so now Cuisenaire rods, let's get started. So what would we actually do to get started with these? Well, first, just let kids play with the rods. You can actually give it to them when they have some downtime. Just let them build their colorful blocks that kids usually really enjoy playing with and building. And just going through that process, they're going to start to get experience with the different lengths and the colors of the blocks. And they'll start to create all different interesting things. Once kids have had a chance to play with them and get some experience, then I'll usually start with having them build this ladder or a staircase. So usually I'll say, everyone take out one of each color and put them in order from smallest to largest. So students will create this staircase. Quite often they've already done this when playing, which is always interesting to see. And then they can count to figure out what each one is. And so you can touch at each one, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But really actually a better way to have them figure them out is to have them actually build the length of each one. So we're going to go through and name each one. I would usually start by noticing that, that represents the 1. The 1 cube is a 1. So then how much is this red? Well, we can actually put together a 1 and a 1 end to end and see that that really is exactly equal to 2. So now I can call this red a 2 or 2 1s. And same thing with the next one. I can take the green and say how long is that? Well, it's actually exactly equal to 3. So I can refer to this as 3 or 3 1s, bringing in a little bit of place value understanding there as well. Now as kids go, so again, the 4, so we're going to now put that there and notice that that's 1 more in length. So this is a 4, so the pink is a 4 or 4 1s. And they can go through and discover each one. It is important, students who struggle or don't have strong understanding of number really need to do this activity where they really determine for themselves exactly what each one is worth. They may have difficulty estimating or seeing a pattern and extending it. So they really need to make sure that they figured out what the number for each one is. But many students are going to be able to start to say, well, all these individual cubes are a little bit of a pain. So how can I figure out what the yellow one is? Well, if I know that this is a 4, I can put that there and say, oh, look, it's 4 and 1 more. So that makes it 5. 4 and 1 makes 5. And they can start to do that with each one and notice that you can actually just add 1 to figure it out. So in the same on the staircase, something you could do if this is the 1, 1 and 1 makes 2, 1 and 2 and 1 makes 3, 3 and 1 more makes 4, 4 and 1 more makes 5, all the way up till they figure out, the 6, 7, 8, 9, and 10. Okay? So when students have had a chance to really discover the length of each one, then we want them to start practicing. So usually what I'll do is have kids play it like a game. First of all, have them keep this ladder or staircase out in front of them when they're practicing with Cuisenaire rods until they really get a good understanding of what each number is. So you can start by saying, everyone take out a 3, and they'll leave that one there and they'll find their 3 and take it out and hold it up. And if they're not sure, they can go back and check, 1, 2, 3. Okay, light green is 3. And the goal is that over time, kids are going to get faster at it. And you can watch as the teacher and see how quickly are they able to figure it out. And then just keep practicing until they figured out what all the different rods are. Another thing you can do is actually hide them and take one rod away. So imagine you weren't watching and I took away this rod and then I put it back together, and then see if kids can figure out which rod is missing and where it is. Oh, wait, it looks like there's something missing there. Oh, that's the dark green, and this is the 5, so it would have to be the 6. And that's a great way to have them also just think of that, hold apart thinking of what's missing from the whole here, and start to visualize that in their mind. So one of the great things about Cuisenaire rods is you can use these to build 2-digit numbers and even larger. So usually what I do, I'm just going to slide this over a little bit, is have students start by the way, a great way to even these out is just to, put a larger rod underneath it, and you can kind of get them straight again. It's a little bit easier than doing it one at a time. So the great thing about these, just like the dot cards, is they only go up to 10. And so you can ask students, well, how would I make an 11? And you have 2 choices. So students will typically be able to figure out 11 is 1 more than 10. So I'm going to take a 10 and 1 more. So I can do a length model like this. Okay, a 10 and a 1. And typically, I do it horizontally, but either one is fine. Or you can do more of a place value model and ask students to put the larger number first. I always teach them to put the larger number first. So 10 and 1 makes 11. Okay, so then how would I make a 12? Well, a 12 is going to be 1 more. So a lot of students will do this, right? And they'll want to take out 1 more. So a 10 and 2 is 12. But then I'll ask, well, is there a quicker way I can make that than the individual ones? How else could I show a 10 and a 2? And usually then they'll be able to figure out, oh, well, I could use this instead, a 10 and a 2, and get 12. And then from there, I might actually jump ahead because I don't want kids counting each time and assuming they know the next one. I want them to think about chunking the numbers. So I might say, well, how about 14? How would I make a 14? Well, 14 is a 10 and a 4. You can teach students that 14 means 4 and 10. So 10 and a 4 makes 14. How would I make a 17? Take that away. That's going to be a 10 and a 7. So I'm going to build it like this. Okay. And again, you can also do the length model where you put them end to end. And for certain activities, the length model is going to be better. And for other activities, the place value model is going to be better, depending on what you're doing. So you want kids to be comfortable building it both ways. And then other things you can do is, you can say, well, now what if I build this? What number is this? And have you build the numbers and have kids figure it out. Okay, that's a 10 and a 9, so that's 19. How about this? Okay, 10 and a 5 is 15. And practice that till kids get really comfortable building numbers, seeing numbers, and recognizing what they are. And again, notice we're just building and talking, so we're developing the concept and the language here. The procedure, the written part, will come afterward. So once students have some comfort with the understanding, you can have them start to write it. But I really want to focus on building the concept and the language first, not as much the writing. We tend to do a lot of writing and math and sort of overemphasize that. So something I want to point out with this is, there's an assessment question of 17 minus 10, and some students actually have difficulty. If they're using that strategy of counting by ones, they try to start at 17 and count back 10 times to get to 7. Well, that's really showing they don't have a good conceptual understanding of number. I want students to know that 17 is built out of a 7 and a 10. So 17, if I minus the 10 or take away the 10, what's left? The 7. If I have 17 and I take away the 7, what's left? The 10. So if they understand that you build 17 with a 7 and 10, it's going to help that strategy. Another great thing you can do with this is actually practice counting by tens, or do 10 more or 10 less. So let's say we start at a 7 and I do 10 more. That makes our 17. 10 more is 27. And let's pause there and just say that before I do this, I would actually want to teach kids how to build these larger numbers, okay? So 27 is going to be built out of a 2 10s and a 7, so how much is 4 tens. 4 tens is 40. So again, teach them that T language means 10. So 20 means 2 tens. 40 means 4 tens. So if I have 4 tens, that's 47. So just like the other numbers, you can practice. You build a number and have kids figure it out. You know, what if I change this to this and I put another 10 here? Well, now 5 tens is 50 and this is an 8. So 58, and have kids touch it as they say it. So they're connecting the language to the visual representation for each one. Okay. Once you do that, then we also can count going backwards with tens. What if I have 58 and I do 10 less? Well, that means take 10 away, 48. 10 less, take 10 away, 38. 10 less is take a 10 away. I have 28. 10 less, 18. 10 less is 8. Okay. So this is a great way to practice both building, adding tens. So 18, 20, and then going backwards so that students get a conceptual understanding of that process. And also it's just important to know that it's great that they're able to recognize they don't have to skip count to know that that's 5 tens, so it's 50. I just want them to see how many tens and then know that that means 50. And I also want to point out that you can use these along with base 10 blocks. And so this one I have here is an orange base 10, and I like that those work together nicely with the same color, but you can see it does have the 10 blocks on it. So typically with Cuisenaire rods, I use them for the 1s through 10s, and then I'll use 100s as well. So one of the other great things you can do with these is actually build multi-digit numbers. So I could build, so how about the number 34, right? That's going to be 3 tens and a 4. Okay. And then if I want to make a 3-digit number, I can add on 100 and put it right here. And again, I'm going to teach kids to build it in the order that they say it, which works with everything except the teen numbers. So 134, and have them touch that, okay? So you could extend this, you know, just like we did the counting by hundreds, then you can, by tens, you can do by hundreds as well. So if I put another one here, now this would be 234. So you could add on hundreds and go up, or take away hundreds and go backwards. And most importantly, just building numbers, having kids recognize what number it is. So there's a real conceptual meaning to those words they're saying, 234. And then they can also use 1,000 rods as well. And you can give them a number and have them build it. So they practice making sense of either a spoken number, if you say the number, or if you write the number, have them build it so they're making meaning out of those different place values. And just like we said, we can use that for counting forward and backwards, and it's a great conceptual way to do that. Okay, another great activity we can do with Cuisenaire rods is making all the combinations for a number. So you can do this with any number, you know, 1 through 10, just like, or even higher numbers, just like we did with the cards. But let's look at 10 especially. So one way to do this, if you've already have your ladder out, you can actually start with that. And again, to even this out, I'm just going to put a rod underneath it. Okay, and that helps to line them back up quickly. So I might say, you know, so look at this. So how much is the orange? The orange is a 10. So, and the blue is a 9. So 9 and what would make 10? 9 and 1. And I can actually have kids put the 1 there. Okay, great. So 9 plus 1 is exactly equal to 10. How about 8? 8 and what would make 10? 8 and 2 would make 10. Okay, 8 plus 2 is exactly equal to 10. 7 and what would make 10? Well, let's say, for example, a student makes a mistake. Let's say they say it's a 4. Well, look, you'll notice, what does this tell you? Oh, that can't be right. That's not the correct length. And so students are going to self-correct, and the processing that's happening in their minds as they figure this out is really the learning we want to happen. Well, they're going to know that's not right, and they're going to know it's too big, so I need to find one that's a little bit smaller. Well, great, there's the 3. And what if, for example, they tried the 2? Well, again, that's too small. They're going to see that, oh, 7 and 2 does not make 10. So I'm going to put that back at the 8 and use the 3 here. 7 and 3 makes 10. So you can actually go through 6 and what? 6 and 4. 5 and 5 makes 10. 4 and what makes 10? 4 and 6. 3 and 7. 2 and 8. 1 and 9, And then think of that pattern. The last step would actually be 0 and 10. So we're going to close it out with that nice 10 there. And students end up with this beautiful pattern here. Well, now let's clarify. Do students typically do this on their own? No, not that great at the beginning. And typically what I do I usually have them build it horizontally. So let's look at it like that. So another way, that's working with a ladder, which would help them go in order. But another thing what I often do is have students just, take out a 10 and say, can you make all the combinations that make 10? And I might start them with the 9 because that usually is the easiest to start with. 9 and what makes 10? Well, 9 and 1 makes 10. Great. And I'll have them, keep going. What else makes 10? Well, quite often students will not go in order. They'll do this quite randomly. So usually what I'll do is come over and just check and say, so do you have all the combinations? Let's say they do this one next. And I'm just going to pull from here. And then after that, they might go back up, to something larger. And if they go out of order, basically students don't know if they have them all. So what I encourage them to do is to do it systematically. What does systematically mean? It means that we have a system. We know where to start, we know what order to go in, and we know what we're done. It's important to help students start to think systematically. That helps to organize their thinking and structure it, which is going to help strengthen and develop those executive functioning skills. And also it's just an important math thinking method is to actually think in an organized, structured way. So I'll encourage them to go in order. Well, 9 and 1, what would come next? So let's do 8 next, 8 and 2, and have students figure that all out, okay? And once they get that whole thing created, so I'll just put it back together, you can then have them practice actually touching them and saying them. So, I would say 9 and 1 makes 10, 8 and 2 makes 10, 7 and 3 makes 10, 6 and 4 makes 10, 5 and 5, 4 and 6, 3 and 7, etc. And go all the way through, ending with 1 and 9, so 0 and 10. And then they've made all the combinations. So you can practice this with the other rods. You could do all the combinations that make 5 or make 8, any one you want to do. And then just practice again. So take out a random rod, 7, and have students take out, well, what will make 7? A 3 will make 7. So then have students hold up, what makes 7. And have them practice like that till they get really great at going in order and figuring them all out. And then doing them out of order and just retrieving those facts from memory.